In this video, we are going to talk about how we rationalize denominators with variables. So our goal is I'm trying to eliminate radicals from a denominator. So when I have expressions like this, sometimes it's helpful to be able to get rid of the radicals out of the denominator. And my idea is going to be, let's try to multiply the top and the bottom of the fraction by something that'll get rid of that radical in the denominator. So let's get right into an example. Let's say I want to rationalize the denominator in the following expressions. So in part A, I got this. And I know that when I have a fraction, I'm allowed to multiply the top and the bottom by something, as long as I do the same thing on the top and the bottom. Like if I were to multiply by 3 over 3, like 3 over 3 is just 1. And if you multiply by 1, it just gives you the original thing. It's not changing the value. That's why this is a legal step. But I don't want to multiply by 3 over 3. I'd like to multiply by something that would, once I multiply the denominators out, it'll get rid of the root on the bottom. Okay, so I want to have you pause for a quick, 15 seconds. Can you think about what you would multiply by so the root cancels on the bottom? Pause it in 3, 2, 1, and think about that. Okay, so hopefully you thought about it. It turns out you got to multiply by another square root of x. Because if you do that, well, square root of x times square root of x, that just becomes x, right? There's a couple of ways to see that. Like square root of x is x to the 1/2, and times another square root of x, that's another x to the 1/2. And now the exponent rule is, well, you add the powers here. And if you add them, you get x to the 2 over 2, which is just 1. And that's just x. The other way to see it is with a quick example. Like if I did square root of 9 times square root of 9, well, I know square root of 9 is 3. And then times another 3, which is 9. So if you multiply a square root by another by itself, the square root just cancels and you just get what's inside. And on the top, you get 1 over square root of x, which is just square root of x. Okay, and now the root is gone from the denominator, and this is what's called rationalized. We've rationalized the denominator. Okay, and we got it. So what about B? What if I do something more complicated? So it turns out that if you were to multiply the top and the bottom, if you were to try the same thing and multiply by like the exact same denominator, 7th root of y to the 10, and they do the same thing on the top, 7th root of y to the 10, what would happen on the denominator is they wouldn't cancel so perfectly. What you'd get is you would end up multiplying the two insides together. So you'd get a 7th root and y to the 10th times y to the 10th. You add the powers, you get y to the 20th. And then as a fractional power, that would be y to the 20 over 7. But that 20 over 7 doesn't simplify super nicely. So this trick where you multiply just by the square root, it just works nicely like that for a square root. For a different type of root, it's not so nice. So then how do we handle it? We can write this instead as an exponent. So I got 3, and let's rewrite the bottom as y to the 10 over 7. And now what I want to think about is, well, what do I multiply the top and the bottom by? I'll give you a hint. It's going to be like y to some power, and then y to some power on top. So that when you multiply out the denominators, it'll end up being really nice. Like I really want y to some like whole number. So I want to have you pause the video for 1 minute to think about that. Can you think of what you would put here as the power? So once you multiply these terms and end up adding the powers, it becomes really nice. Okay, so hopefully you did that. Hopefully you paused the video to think about that. So there's a number of things that we could do. One thing that's really nice is if you did 4 over 7. If you did 4 over 7 there, you got to do it on the top. Because now what you'd get on the bottom is you'd get y to the 14 over 7. Ooh, and 14 over 7, that's just 2. I get y squared. Ooh, that's gotten rid of the root because we have this whole number power. And on the top, well, we just have 3 times y to the 4 over 7. I can't really simplify that further because like we don't have the same base with these numbers. It just stays as 3 and then times y to the 4 over 7. And now we've gotten the root out of the denominator, so we've rationalized the denominator. Okay, and there we have it. So let's talk about one other type of example. So what if I have like a root and then plus something or minus something? We need something called a conjugate to help with this. So when you have two terms added together, like a plus b, the conjugate of it is, you're going to just switch the sign. It'll be a minus b. So these two things are called conjugates. It turns out when you multiply conjugates, it simplifies really nicely, because I could FOIL this out, and if I FOIL it, we'd get a squared. Multiplying the outers, I get minus ab. Multiplying the inners, I get plus ab. And then multiplying the last terms together, I get minus b squared. And then I notice minus ab plus ab, well, that just becomes 0. So we're just left with a squared minus b squared. So when you multiply something by its conjugate, these things in the middle cancel, and you're just left with a squared and then minus b squared. And that's really nice when you have like a square root plus something or a square root minus something. Because if you multiply by the conjugate, you'll end up squaring the first thing, which will get rid of the root, and end up squaring the second thing. So let's try that in an example. Let's say I want to rationalize this fraction. So I don't just have one root by itself. That's why this thing won't be as helpful. Let's try multiplying this by the conjugate. So I'll do that on the top and the bottom. So the conjugate of this is, change this sign to a minus. I'll get 2 and then minus root x. Same thing on the top, 2 and then minus root x. So, okay, when I do this, on the top, I'll keep it factored as 3 times 2 minus root x. On the bottom, let's multiply it out. Let's FOIL it out. So when I multiply the first terms together, 2 squared, I'll get 2 squared. When I multiply the outers, I'll get minus 2 root x. Multiply the inners, and I get plus 2 root x, plus 2 root x. And I multiply these last terms together, and I'll get minus, and then square root of x getting squared. And now, just like we saw up here, when you multiply by the conjugate, well, these middle terms are exactly opposites. So they will just become 0. So what it leaves me with on the top is 3 times 2 minus root x. And on the denominator, well, 2 squared just becomes 4. And then the square root of x, once you square it, well, it cancels the root, like we've seen that. So you'll just get minus x. In fact, the more of these that you do, you'll start to get comfortable with just recognizing, oh, when you multiply something like this by the conjugate, you just end up with this first thing squared, a squared, and then minus the second thing getting squared, minus the b squared. Okay, and that's our answer. Okay, this last example here, rationalizing a numerator, we'll practice this together in class. I'd encourage you to pause the video even now to try that on your own. It's a good way to see how well do I understand it, but we'll bring it back together in class to go over this.